In this project, we'll show how to design a chip interposer board. Now, the purpose of a chip interposer is to convert the footprint that you see on a PCB, such as this footprint, into a footprint for a different component, such as this footprint. So, the pads on this side would mount to another PCB that maybe has an incorrect footprint or that you just want to swap out. And this top side footprint is where you would now mount a new component. So these interposer boards are very useful in prototyping. They're also very useful if you make a mistake in a prototype and need to very quickly correct it. So make sure to hop into Flux and follow along.
Hello everyone, and welcome to another Flux tutorial. In this design tutorial, what I'm going to do is show you how to design a chip interposer. Now, sometimes when you have a board that's going through fab, it isn't until after the board is fabricated that you realize that there is an incorrect footprint in the board. Sometimes you have an existing board and you just want to be able to update that board to a new component without having to refabricate that board. So what can you do in that case? Well, what you can do is you can design a chip interposer board. Now, Flux is probably the fastest platform for doing this just because it has all of these standard footprints available in the public library. I'm going to show you how to leverage the public library in Flux to do this very quickly, and I'm going to set a goal for myself. I'm going to time myself to try and get this done in about 10 minutes. That's kind of an ambitious goal for most CAD platforms, but I'm going to try and do it in Flux right now. So make sure to hop into Flux and follow along. So first things first, what are we doing? Well, what we're going to do is we're going to look at a hypothetical situation. Let's say we have a board that we need to match to a new component. Now, the board already has a footprint that matches SOIC 8 package. So it already has this footprint somewhere on an existing board. Instead of using this component, we want to instead, after the board's been fabricated, translate it into this component, which is a different package. So it's an 8 TSSOP package. How do we do that? Well, what we can actually do is we can design a small board that converts this footprint into this footprint. And it's actually really easy to do in Flux because all of these different footprints are available in the public library. All I need to do is just, for example, search for a package size like TO220, and more than likely you're going to be able to find some component that already uses that package somewhere in the public library. So to get started with this, first, of course, I want to define my translation between this footprint and this footprint. And so to do that, I need to take what is my existing component and then define net connections to whatever my new component is going to be. So the first thing that we want to do is actually take this component and we want to then clone this. So the reason I'm cloning it is because I want to have a copy of this component that I own, and because I own it, I can now modify the pinout so that it matches the actual component that I'm going to use to then match up to this existing footprint in my board. Now, the reason I want to do that is because I want to get access to this footprint. And so that's one of the cool things about Flux is this footprint is already available in this component from the public library. Since it's publicly available, I can just make a copy of this. I can rename all of these pins. So for example, I can rename this SDA terminal as whatever the actual terminal name is on the actual component that I'm going to use in my PCB. So just as an example, I'm changing this to DIN, DOUT, and we'll call this SCK. So this is for a SPI interface. So now I have my component that I've just created. We're just going to call this fake component because this is just a kind of a simple example here. But once I've created this dummy component that I want to translate and interface into this board, I can then publish this to the library. Now once I've published it, it's only going to be visible to me, but then I can use this in my chip interposer to then create the translation between the two components that I want to use. So remember, this is my existing footprint that's in my existing hypothetical board. I want to translate it into this new footprint. So I'm going to show you how to do that now, starting from the schematic. So inside the schematic, this is my existing component that I want to start with. Now I'm going to look up my fake component here that I just created, and I'm going to drag this in. Now at this point, what we would need to do is, of course, make the net connections that we want to then translate between this component, which exists in our PCB, and then this new hypothetical component that we then want to use in our assembly. So we have several connections that we would need to make. I'm just going to kind of trace a few of these out. Again, this is a bit of a contrived example, but it's going to become clear in a moment once we get into the PCB. So now we have some net connections defined between our new IC that we want to use in our assembly, and then our existing footprint on our circuit board that we need to translate away from. So how do we then create this interposer board? Well, first thing we need to do is we need to set the size of the board. And then because this is going to be the component that we are translating into this new component, we need to set this pad on the back layer. So we need to set all of these pads on the back layer. So first thing I'm going to do is just, of course, flip layer. And then what I'm going to do is I'm going to change the layout. And I want the layout size to then match whatever this package size is. Now you can see here we have a pretty good documentation for the package size. It's 3.9 millimeters by 4.9 millimeters. So what I can do for my object-specific rules, or for the layout rules, is I can then change the size to 3.9 mm and 4.9 mm. So that shrinks down my layout. It actually makes it a little too small, if you can see here. So I'm going to have to increase the X dimension just a bit. Again, I can just go over to my layout, and we're just going to make this, let's say, 4.9 millimeters. Let's see if that's big enough. Looks like we need to keep increasing it. Make this 6.9 millimeters. There we go. So now we're just starting to cover up the pads here. So now this is the component that we're going to translate out of. And I'm just going to do one more board size increase just for good measure, so that we've got enough room around this edge that a fabricator is not going to complain about this if we then go to fabricate it. So the next thing that we need to do here is we need to actually go through and modify the pad arrangement on U1. Now notice here that when I took U1 and put it on the back layer, it actually takes that component and flips the pad orientation. So because that pad orientation is flipped around, you need to just check the pinout here on this pad compared to the connection that you need to make here on this pad for these components. Now, once I've got that pinout verified and I have these connections verified onto these pads, I can then take my IC that I want to use in my assembly, and then I can just drag it over here. And once I do that, and just turn off some of the bottom layers so that things are a little bit clearer, I now see exactly what is going to appear in my final assembled PCB. So this is going to be my top layer. My top layer is going to have this integrated circuit assembled onto it, onto this carrier board. And then the bottom layer is going to have this other integrated circuit footprint on it, but nothing is actually going to be assembled onto this bottom layer. So what we would want to do in our bill of materials is take U1 and then we want to mark it DNI. So once we go up here to the top menu, we go up here to export, we export our bill of materials. Just make sure you open up that bill of materials and mark U1 as do not populate, do not include, do not mount, some sort of note that says there's no component to assemble here. We're taking advantage of this only for the footprint, so that way we can interface it back to this other component that we actually want to include in our PCB. So now that IC1 is placed here on this top layer, you can see that we have our net connections between our footprint on the bottom side of our board and our chip that's on the top layer. And so now all we would need to do is then, of course, add in any vias and traces that we need in the layout to complete these connections. Now you can make these chip interposer boards as simple or as complex as you want, but I would recommend making them simpler. Simpler is definitely better in this case. Now the reason for that is because, of course, you don't want to make this thing too complex, because then it's going to take too long to fabricate and it's going to be kind of expensive to fabricate. I think simpler is definitely better here for that reason. Now, once I have this, let's say this via placed right here, I can then of course route from here over to this via, and then once I'm on the back side, I can then route from this pad over to this via, and then you can see here I've completed this connection. And so I can do this across the rest of this PCB for the rest of these connections. So that's pretty simple, and anybody who's following along with this, it should take you just a few minutes to finish that up. Now, I've gone over my 10-minute goal that I've set for myself, but I think that's okay. Here, I want to just point out the important part of this, which is I'm able to leverage these existing footprints that already exist in the public library in order to create these little interposer translation boards. So that's really convenient, because if you use other CAD systems, you may have to design each of these footprints from scratch. You might have to then just hope that you have them in your library, or if it's a really unique component, you have to then maybe build it yourself, or you have to hope you can find it from the manufacturer. With the Flux platform, all of these common footprints are actually going to be readily available here in the public library. And so if we wanted to translate from U1 to, say, a different IC1, well, then all we would need to do is just look up that alternative TSSOP8 package in the public library, and then we can pick a different component if we like. So this is really convenient because you have access to all of these different footprints simply because you have access to these different components in the public library. And then once you drag this in, you can of course just start using it in your project immediately. Or if you want to then modify this component and create something new, you can right click on it and click open. You can also just click right here on this link. It'll immediately open, and then you can clone it as I did before. Once you clone it, you can start modifying this component, and then you can create whatever component you need to then put onto your chip interposer so you can then finish your design. Now, one thing I'd like to note when you're creating these chip interposers to translate between these two footprints, one thing I think that is important to keep in mind is, of course, making sure that this layout is as simple as possible. And so, of course, the main reason for that is to reduce your cost and then your fabrication time. So, what are some of the simplest ways that you can reduce the cost of this? Well, the first is just to go over to the layout and then set the stack up to be 2 layers. So there's no reason to use 4 layers in this interposer unless you absolutely need it. Now you can set the stack up here just by hitting edit, adding in an object specific rule, type in stack up and add it. And then once you've added that stack up rule, you can just select standard 2 layer, and then it's going to remove those 2 inner layers. So now you're only routing on top copper and bottom copper. Now, if you have a really complex interposer that you need, of course, you can set any number of layers here within this drop-down box. So all the way up to 12 layers. So that's very useful. The other thing that you can do is check here on your via size. You want to make sure that these vias are not too small. So if your drill size or your drill diameter is too small, Fabrication House is going to charge you more because those smaller tools wear out quickly. So what you would want to do is just check the hole size for these vias. And so to do that, you can just add in an object-specific rule, type in hole. You'll see here there's an option for hole size. I just click add. And so what I would do is do this in 14 mil hole size, and then make sure that the size of the via in terms of the pad size is large enough to leave enough pad here so that you don't split any of these traces. So you want to leave some annular ring. So to do that, you would just use the size rule. We're going to add this, hit done. And so a good safe value here for a 14 mil hole size would be a 22 mil pad size. Okay, so this is a good via size to use. It's going to be large enough that any fabricator on the planet is going to be able to fabricate this, and they're going to be able to do it for low cost. Finally, of course, as long as you have a ground net here on this board, you can then include the copper pour. That's going to provide nice uniform ground connections between the top and bottom side pads. And then finally, when you're done, you can go up here to the top menu, and then you can very quickly export everything. And once you've exported everything, you can send it into a quick turn fabrication house. They're going to be able to fabricate this board for not a lot of money, and usually they can send it out next day, and then you can continue on with your assembly and get your manufacturing run wrapped up. So I spent some time to go through and finish up the routing, and this is what it looks like. There are just a couple of things that we need to do to get this cleaned up and ready to go. One thing that we have to do is, of course, you should notice that on the bottom overlay, we have a reference designator that is outside the board. Simplest thing you can do is just drag it in here. I would recommend that if you created these footprints on your own, that you go back and you check all of the overlays to make sure that you don't have any silk screen that's overlapping with any exposed copper. So this overlay looks like it might be overlapping with the exposed copper. You just want to go and check that in the footprint. The other thing that we want to do is, of course, make sure that these vias are manufacturable. We did set that earlier, but we also want to make sure that we don't have them inside of any pads. Now here you can see that they're not inside any pads, but if you had a much larger and much more complicated interposer that you were creating, there is of course the possibility that one of these vias sits in the pad. Now the reason I bring that up is because this is an interposer and we want to fabricate it cheaply. And if you put a via in the pad, it can still be manufactured. It's just that the cost goes up because then you have to do plugging and capping in order for that interposer to be fabricated. So keep that in mind. We want to try and optimize this for cost, and that means keeping these vias out of these pads. At this point, we're essentially done. Don't forget, of course, to DNI or DNP or use the mount rule to ensure that the bottom side component is not going to be attached to this PCB. And that's everything that we have for this interposer board. Thanks everyone for watching this video. I hope this has shown you how quick and easy it is to leverage the footprints within Flux to create these kinds of translator boards. Like I said earlier, other CAD systems are going to force you to build some of these footprints from scratch. That can get kind of annoying because, I mean, let's be honest, nobody likes to build footprints, and it's always nice to be able to leverage some of that existing CAD data from a publicly available source like the public library in Flux. Make sure to hit the subscribe button to keep up with all of our design tutorials and updates, and thanks for watching everybody. We'll see you next time.